Hey everyone, and welcome to another edition of the Zcast. This is Mr. Z, and today we're going to talk about thinking like a scientist. And as we do that, what we're going to do is we're going to talk specifically about leaves, trees, identifying things, and a bunch of other stuff related. This is a type of leaf, and it's an unknown, and we're going to try to classify this guy, figure out what it is, but first we have some steps to take along the way. Okay, so our first one is a skill of observation. Observations are when we gather information from our surroundings by using our senses. So we look, we feel, we smell, we do all those things. Well, the first thing I want you to look at with leaves, however, is that there are a lot of observations we can make. We can look at the outside edge of the leaf, you can see here. We can look at the branching. Notice one comes out on one side, then the other, then back and forth. We can look at the petiole, which is a really weird word for a stem. You see over here, the stem's look kind of round. And so we observe some stuff, and then we use those characteristics to do other tasks. Now, when you look at this tree here, one of the things we notice is we've got several different colors. We get the green, and we have that starting to turn yellow, and then we have this brighter colors up here. And so we can draw some inferences. Now, an inference is when we take our observations and we use what we already know and past experience or reasoning, things that make sense, to draw further conclusions. Well, if you saw this tree up here in New York State, upstate New York, you might think, we're headed towards winter. Because when leaves go from green over here to these colors, what's happening is the chlorophyll's draining out of them and the leaves are about to fall off. Now that's an inference, and I got that because I've lived here for at least one fall, actually quite a few. And in the fall, this is what happens. Oak trees, in this particular case, they turn like a deep red color, orangey red color, and then they fall off. And so that happens every winter. The next skill we use is comparing and contrasting. We take those skills of observation and inference and we deepen them a little by describing how different things are similar or different from each other in characteristics or behavior. And one of the things I want to show you here is these leaves on the left. You can see the word, the word we're going to talk about, simple. Simple means it's just one leaflet, which is this green part, and one stem, one petiole. This guy on the right, which happens to come from an ash tree, or could be hickory as well, is we get these leaflets, and there's many of them on one petiole or one stem. That's actually one leaf. This whole thing is one leaf. And then you got this guy over here, which is what's called double compound. It's pretty rare, that guy. There's some examples of those. You see them on ferns sometimes. But what I'll walk you through here is you see this is not the leaf. This is not the leaf. It's this whole thing is one leaf. Pretty crazy. So we see that occasionally in nature as well. So we compare and contrast them, say how they're different and alike, and that helps us just to learn about things. All right. So here we see really the goal of it all is to classify. Classification is when we take all those skills of observing, inferring, comparing, and contrasting, and we start to group things together based on their comparisons, and we separate things based on contrast. When we look at leaves, we look at several things. We would look at the margin. You can see that right there. These pictures that I just got from a Google search. And the margin, or the end of the leaf, the outside edge, could be all of these different things. And we tend to see double serrate. We see serrated. We see entire, which is right over here. It means it's just one big smooth thing. We see some lobing going on and other things with leaves, and that helps us to say, oh, these belong together and these don't. And one other thing you can look down here is we see branching. When leaves come off, and sometimes even branches come off on a tree, they come off, like you can see here on the left, opposite each other. One branch comes out and the other one's directly across from it, like your arms would be coming out of your torso. But sometimes they alternate. You can see there's one on the right, one on the left, one on the right, one on the left. So as we look at some of these characteristics of leaves, like the outer edge, the branching, whether they're simple or compound, all that information goes into us being able to classify them. Okay, so here's our example. Let's see what we can figure out before we go to a key and take a look at this guy. We have simple leaves. You can notice right there is where they sort of stop. It's one leaf. Well, besides being simple, look at the branching is alternate. I don't know if that'll come up or not, but it's alternate. So there's one here, then there's one there. It's not opposite. And these guys are lobed. You can see the lobes go in and out like that. And the type of lobed that we can talk about is something known as pinnately lobed. In other words, that we have one lobe comes off to the right, one goes off to the left. And they don't all come out of what would be like your hand. You know, your hand is a palm. Okay, so let me see. There's your thumb. 1, 2, 3, 4, as long as you're not weird. All of these fingers and your thumb come out of one spot. And so sometimes we see leaves that come out like that, and they all come out of one central point, okay, like that. And maple leaves do that. I'm just not a very good artist with my finger. So that type of plant that does that is called palmate, like your palm, palmately lobed. Where these guys, you could see a line down the center, and then they're coming out on the sides. Well, that's called pinnately lobed. And so they're lobed, but they're pinnately lobed. And now we can use all that information to classify and find out what kind of tree this is, although some of you may already know. Okay, so now we're on to keys for classification. A scientist or person might use a key to classify something, and it helps you either identify or organize or classify objects and organisms. The one I have in this web window open right here, I'll just pull this up a little bit, is one, get it over here to the side. It's one that is used often. It's called a dichotomous key. Dichotomous, DI, stands for two choices, and dichotomy means that it can't be both. It's got to be one or the other. This isn't a true dichotomous key because, as you're going to see, in the beginning you see this number 1 here. It says a tree with needles. But besides that, there are two other choices. Let me get into this here. So it could be a tree with needles, it could be a tree with scale-like leaves, you can see at the top there, or a tree with normal leaves. Now, if we go back and use our sample from earlier, we're going to click on a tree with leaves. And what it's going to do is take us to another choice. In this case, a simple leaf, which we talked about. This is a simple leaf. Or a compound leaf. Well, we have a simple leaf. And then it's just going to keep going, whether it's unlobed or lobed. We had a lobed leaf. And then each time you make a choice between two things, is it unevenly balanced or is it balanced? And ours is balanced. Oops, wrong thing there. Let me move over here. Got to get my arrows back. And then we'll move back over here. Okay, so it's balanced. And let me get this thing out of the way. Okay, and then it asks palmately or pinnately lobed, and we got this guy right here. And now you can see we're dealing with the oaks. Is it a white oak or a red oak? And you get the idea. There's American holly is another one that kind of fits in there. But this is a dichotomous key that might help a scientist to figure out, just what something is. Identify an unknown tree. Let me give you another one. Here's one that you might use, say, in class. You have a dog, you have some sort of flower, a bird, a fish, a tree, a single-celled organism, a snake, and then a sponge. And so by going through, you'll see two choices, 1A, 1B, an organism with 2 or 4 functional legs, organism with 2 or 4 legs, okay? I'm sorry, without 2 or 4 legs. So you can see, the dog, the bird, that's it. They have functional legs. So if we say that's true, we're going to go down to number 2. And in number 2, it's 2A, 2B says organism without wings, then it's the dog. And if it is wings, then it's the house sparrow. So each time you're going to ask a series of questions or statements for each one. So let's say we choose the king cobra, okay, or the cobra there in number 7. So we look at number 1, and 1A and B, the two choices, dichotomous. And it says 2 or 4 legs, okay, nope, so we go to number 3. Now we have two choices for number 3. Is it unicellular? Nope. It's multicellular, so we go to number 5. Is it heterotrophic or autotrophic? Wow, big word. Autotrophic means it can make its own food. Heterotrophic means it can't. So, can a snake make its own food? Yeah, I don't think so. So, moving on to number 6. And number 6 says it lives in the ocean, it lives on land. Well, since it lives on land, number 6B is a king cobra. All right, so that's kind of how dichotomous keys work. Those are the kind you're going to see. And I hope you got everything from classification and compare and contrast, observations, inferences, all that stuff that we covered this week. Awesome.